Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about subset notation. So let's start with an idea we're already familiar with inequalities to guide us in this field. Just pause the video for a second and state the meaning of each of the following symbols. Well, the first one means strictly less than. The next one means less than or equal to, and the last one means is not equal to. So giving some sentences there, I may say that 2 is strictly less than 5, let's say. I could say, in theory, although this is a slightly silly statement, I could say 5 is less than or equal to 5. It's not less than 5, but it is equal to 5, so that statement is allowed. And I could say again that something like 3 is not equal to 5. Right? Now there, when we're comparing numbers, sometimes we want to compare sets and the size of sets and how they are in relation to each other, and we use what's called subset notation. So let's have a think about these and introduce them. Okay, the first symbol, it's a little bit like the less than sign. Similar idea to that, but with sets. If you see this symbol here, it means is a subset of, but is not equal to. And another way of saying that, the technical term, is to say it is a proper subset of. Now what that means is, let's say for example I gave the statement A is a proper subset of B, or A is a subset of but not equal to B. That would mean that A is smaller than B and it is entirely contained within B, like that picture there. That is the only way something can be a subset of another thing. A is entirely, the whole set of A is entirely contained within B, so A is a proper subset of B. Okay, the next one. This symbol here is a subset of and can be equal to. It's a little bit like the less than or equal to sign. So the only scenario really you can have for this is if two sets were exactly the same, like I'm trying to draw here, A and B were the exact same, you could in theory say that A is a subset of B, and equivalently you could say B is a subset of A. In fact, later on when you're trying to prove two sets are the same, that's the way you prove it. You prove one is a subset of the other and vice versa, the other one is the subset of the other. That's how you tend to prove two sets are equal. But that is the use of that symbol, which we'll rarely come across. Now the next one is a bit, it means is not a proper subset of. So let me show you some examples of if A was not a proper subset of B, like that. Well, A could be entirely outside B, like that. A is certainly not a subset of B there. A could have some overlap with B, but it is not entirely contained within B, so again in this scenario A is not a proper subset of B. Okay, so they're the type of pictures that would apply to. And the last one, we've come across this notation before, that there means the empty set. Okay, that is the set with no elements of it, and there is a rule that we're going to come across later. The empty set is a proper subset of any set. Is a proper subset, I'm going to write that, of any set. That's just a rule. Okay, so sometimes we have to list the proper subsets of sets, and we always state that the empty set is one of those subsets. Okay, so let's try some questions now that we're familiar with the notation. We're going to have a few true, false statements, and you've got to decide whether any of these statements are true or false with the symbols here. Okay, here's the first one. So pause the video and have a think, looking at that picture, if any of the false statements there are either true or false. Okay, the first one. Is A proper subset of B? Is A entirely contained within B? No, it's not. A is bigger than B. In fact, B is entirely contained within A. This is certainly false. This is not true. Now, the next one. This says A is not a proper subset of B. That's definitely true. We've just said if the first one, if A is not a subset of B, then we can say this statement, A is not a proper subset of B, must therefore be true. Okay? Is B a subset of A? Yes. B is entirely contained within A, so this is also a true statement. Is the empty set a subset of A? Yes. Remember I told you the empty set is a subset of any set, so that is certainly true. Okay, the next one. Pause the video and have a think through these. So is A a subset of B? Well, A is less than B, so you might think it is, but A is not entirely contained within B, so this is a false statement. To be a subset, you must be entirely contained within another set. So therefore, the next statement must be true. A is not a proper subset of B, so that statement must be true. And the last two statements are both true. Remember, the empty set is a subset of any set, so that is always true. Next, have a think about this. Okay, is C a subset of A? Is C entirely contained within A? No, it isn't. C is bigger than A. In fact, C entirely contains A. So this is definitely a false statement. Is A a subset of B? Yes, A is entirely contained within B, this big circle here, so this is true. Is A a subset of C? Yes, this A here, this little circle here is entirely contained within this shape here for C, so this again is true. Okay, next one. Pause the video, have a think here. Right, is C a proper subset of A? Is C entirely contained within A? C here, this is entirely contained within A. That is certainly true, so we'll write true there. Okay, the next one, some combinations. C or D. Is C or D a subset of A? Well, C or D is everything in C and everything in D, or both. There is no both in this case. Now, there is the picture of C union D. Is that entirely contained within A? Absolutely it is. So this again is a true statement. Next one. This says D is not a proper subset of A intercept B. Let's draw A intercept B. A intercept B is everything where A, this here, overlaps with B. And that's got to be in this section here. Right? So is it true that D is not a proper subset of that? Well, D is a proper subset of that. D is entirely contained within A intersect B, so this statement must be false. And the last one, is D a proper subset of the complement of C, of not C? Everything outside C would be everything outside this circle here. And would it be a fair statement to say that D is entirely contained within the shaded region if we were to colour it all in? D is certainly contained entirely within this shaded region, so this must be a true statement, and we're done. Okay, last example here. The picture's not drawn for us, so pause the video and have a go at this. Okay, we don't have a picture in this case, but we could list out the sets and see if that helps us answer are these various questions true or false. So, the universal set is a set of x, the integers between 0 and 13 inclusive, so they are as follows. Okay, the next set is the set A, and they're the integers that are bigger than 0 and less than or equal to 12, so I'll list them carefully underneath. Okay, the next ones are the multiples of 3 that are in the universal set and bigger than or equal to 0 or less than or equal to 13, so they're going to be as follows. They're going to be 3, carefully draw them in line, 6, 9 and 12. And the last one are the factors of 15. So let's just go through the universal set and see which one's a factor. 0 is not a factor, 1's a factor, 2's not, 3 is, 5 is, and that's our only factors. So there you go, we have listed out these sets here, and we should be able to answer these questions. Is B a proper subset of A? Is B, the elements in B, all of them entirely contained within A? 3 is in A, 6 is in A, 9 is in A, and 12 is in A, so this is a true statement. Is B entirely contained within C? Is it true that B, all the elements of B, are in C? No, that's not true at all. Okay, they only actually share one element in common, so this is false. Is C entirely contained within A? Is C a proper subset of A? Are these three elements all in A? They are. 1 is, 3 is, 5 is. This is true. Is 6, the set of just the element 6, entirely within C? Is 6 in C? No, it's not, so this is false. Is 1 entirely contained within B? 1 is not contained within B. You can see 1 is not an element, so that's false. Now, is B intersection C entirely contained within A? Well, what are the elements that are both in B and in C? Let's try and list them. What elements are in B and C? There is only one such element, which is 3. Now, is 3 entirely contained within A? Absolutely. Look, it's up here. So this is a true statement. And lastly, is B or C contained within A in totally? Well, B or C, there'd be the elements 1, 3, 5, 6, 9, and 12. The elements in B, in C, or in both, and they are all entirely contained within A, so that is a true statement as well. And that's it for this particular video. Thanks for watching.